Okay, so in this video we're going to derive the formula or the integral for arc length. Okay, finding the arc length of a polar curve. So we're going to start with the formula that we derived for the rectangular, with rectangular coordinates when we had a parameterized curve. Okay, so in that case we had our point x of t and y of t for some parameter from 0 to b, or excuse me, a to b. And so this was the formula that we derived. Okay, so that the arc length was equal to the integral of the square root of the derivatives squared, right? So that you see here. So now, in order to derive the analogous formula for polar curves in polar notation for polar coordinates, we're going to say, okay, we're going to use r as a function of theta, where theta is on the interval from alpha to beta. And so we're going to use these formulas in order to help us. So y equals r, well, let's start with x. So we alphabetical order. So x equals r cosine theta, which r, because r is a function of theta, we're going to use f of theta times cosine theta. Okay? And then y is r sine theta. And so again, we're going to substitute in f of theta for r. So we get f of theta times sine theta. Okay, so we're going to start with that, and then what we're going to do is we're going to replace the parameter t with the parameter theta. Okay, so what we're going to do is we're going to use theta as the parameter, just like we mentioned before in earlier videos. We did the same sort of thing. Okay, so now we've got parameterized equations or parametric equations in terms of theta. Okay, so theta is the parameter. Okay, so what do we get? Well, since we're replacing t with theta, well, now dx d theta is what? Well, it's the derivative of this thing with respect to theta, so we're going to have to use the product rule here. So this is going to be f prime of theta times cosine theta minus f of theta times sine of theta. Okay, so I just used the product rule here, okay, for this, because I've got a product of two functions, in theta. Okay, so I took the derivative of the first times the second plus the derivative, the first times the derivative of the second, but the derivative of the second is negative sign, right? So the derivative of cosine is negative sign, so that's where the subtraction comes in. So now let's do the same thing for dy. dy equals d theta, and so here we're going to use the product rule here. So again, we're going to get f prime of theta times sine theta plus f of theta cosine theta. And so that's what we're going to use in our formula. Okay, so now we're going to replace dt by d theta, and the upper and lower limits of their integration are going to be alpha and beta, respectively. So then the arc length function becomes this. Okay, so what are we going to do? So I'm going to leave this here for a minute. So we're going to change this, right? So what happens to our arc length formula? Well, it becomes this. So we get dx d theta squared plus dy d theta squared d theta. And our limits, oh, I'm sorry. I forgot the integration. I was going to say, I thought it was there before. So this is going to go from alpha to beta now, instead of a to b. Okay, so there's the function. Okay, so now, let's do some more substitutions. Okay? Because I don't want x and y in there, right? We don't want x and y in there. So let's make our substitutions here. Okay, so I'm going to substitute in here, and this is going to be equal to the integral from alpha to beta, and this is going to be the square root of what? It's going to be f prime of theta cosine theta minus f of theta sine theta quantity squared plus f prime of theta sine theta plus f of theta cosine theta quantity squared d theta. Okay, so all I did was substitute in these two for these two. So now I'm going to erase those. And so now I'm just going to simplify what we have here. And so what can we do here? Okay, so we're just going to FOIL, so let's see. I'm going to start over here, give myself some more room. So this is going to be the integral from alpha to beta Okay, so what's going to happen here? Okay, so this is going to give me f prime of theta squared cosine squared theta, and it's going to give me minus 2 f prime of theta f of theta cosine theta sine theta plus f of theta squared times sine squared theta. Okay, so that's that piece. So then plus, well, then the same sort of thing is going to happen here. So this is going to be f prime of theta squared plus, what do you get? You get 2 times f prime of theta theta sine theta cosine theta plus f of theta quantity squared cosine squared theta. So all of this is still under the radical. Okay, so this is just a continuation of this. Okay, so again, just to reiterate, so all I did was expand this and add them together. So I've got this whole thing plus this whole thing under the radical. Okay, so this line is not a division sign. It's just a continuation of the radical to the next line. Okay, so now, this is great because luckily things cancel out. So here I've got minus 2f prime of theta, f of theta times cosine theta, sine theta, and here I've got plus 2 the same thing. So this, thank goodness, this cancels with that. Okay, so that's going to make things a lot nicer. So now, what happens? This is going to be alpha, beta. Now what do I have here? I get f prime of theta squared, cosine squared, hold on a second here. Oops, hold on, I'm missing one. This should be, hold on. Oh, this should be, there we go. I dropped the sign there. Okay, so I got f prime of theta squared cosine squared theta, and I've got an f prime of theta squared sine squared theta. So I can put those together. So let's see how this works. So I'm going to put those two together, the things with the f prime of theta. So I get f prime of theta squared, and I get cosine squared theta plus f prime of theta squared times sine squared of theta okay, and then I've got f of theta squared sine squared theta, and I've got an f of theta squared cosine squared theta. So I'm going to put those together, so that's going to be plus f of theta quantity squared sine squared theta plus f of theta quantity squared cosine squared theta d theta. Oops, I dropped the d theta here. Okay, so now what do I have? I've got a common factor here that I can factor out, and I've got a common factor here that I can factor out. So what does that give me? Gives me this. So now this is going to equal, so L, the arc length, equals the integral from alpha to beta of what? It's going to be f prime of theta squared times cosine squared theta plus sine squared theta plus f of theta quantity squared times cosine squared theta plus sine squared theta d theta. So now, well, another thing happens. Well, we know that this is going to equal 1, and this is going to equal 1. So that makes things a lot easier. So now what do we get? We get what? Well, we're just going to replace those with 1. And we get this. We get f prime of theta, quantity squared, plus f of theta, quantity squared d theta. Okay, so now, that simplified things quite a bit. But what is f of theta and f prime of theta? Well, easy, right? We'll go back. What's f of theta? What was f of theta defined as? R, right? And what's f prime of theta? Well, if f of theta is r, then guess what? Then this is going to be dr d theta. And so our final equation for L becomes the integral from alpha to beta of the square root of r squared, so this squared, plus dr d theta, quantity squared, d theta. And that is the formula for finding the arc length of a curve in polar coordinates. Okay, next I'll do the theorem. We'll introduce the theorem and we'll do some examples.